All right, we've dealt with right triangles. This whole chapter is about right triangles, but actually this section right here is dealing with triangles that are not right triangles, even though it's in a chapter that's about right triangles, okay? Now, there is a reason why it's in the right triangle chapter, because the proof, I'm going to give you two rules that we're going to learn. And in order to get these two rules, and in order to prove these two things, you have to know about right triangles, okay? So you would deal with right triangles to get to this. I'm not going to prove it. We're not going to go through and show you why these things are the way they are. Um, and there are proofs out there. You guys talked about Khan Academy. I think Khan actually does a proof on the law of sines and the law of cosines and shows you exactly how they came up with these formulas. I'm just going to show you what the formulas are and show you how to use them. Okay, I'm not going to show you how we came up with them. But if you're really interested in that kind of thing, which I kind of doubt you are, but if you are interested in that, you can always go to Khan Academy, look for these two rules that I'm going to show you, and one of the first lessons on there is going to be the proof form. They're going to show you how they got these formulas. All right, but let's talk about these two things. The first thing, let's go in order the way they do it in the book. Usually I teach the other one first, but they go in this order. So it's called the law. You should write this down, okay? If you don't write this down, you are not doing everything you need to be doing, because this is not one of those things where you're just going to say, sit there and just look at it and do your vocabulary, okay, that kind of stuff, and be able to figure out how to do this, okay? I'm in a serious mood. I'm not in a bad mood. I'm in a serious mood because this stuff that we're teaching today, it's very important. It's not all that easy for some people, okay? So I want you to get serious as well, and I want you to pay attention. And I'm just in a serious mood, okay? And I want you to take this seriously. Yes. 3 and 4. There you go. Watch. Here we go. Law of sines. Okay, the law of sines. Now we've already dealt with sine, cosine, and tangent. With the sine, cosine, and tangent, we call those our trig functions. All right. So those three things are our trig functions. We use our trig functions only when we're dealing with a right triangle. But today what we're going to do is we're going to talk about another triangle that's not a right triangle, and you're going to have a couple rules to be able to solve for either some angles or sides, whatever the case may be, with these different laws. These are non-right triangles, so these are all used, and they are not what? Right triangles. The trig functions, the sine, cosine, and tangent, all that stuff, SOHCAHTOA, all that was only used with right triangles. This stuff is used with non-right triangles, okay? If they are not right triangles, this is what we're going to use. Everybody got that? All right, so here it is, the law of sines. We'll do that in blue. I might write it just a little bit differently than they do, but this is just how I do it. It all depends on how the problem's set up, on how you want to write it. So I'm going to write it like this. Little a over sine of capital A. Now what's the difference between the lowercase a and the uppercase A? Good. The uppercase, the big A, is the angle. Okay, it's talking about an angle. What's the lowercase a talking about then? So if I had a triangle, watch, before we go on with this law of sines, I tell you what, let's just finish writing out the law of sines and then we'll talk about it, okay? It's a little bit different than you've seen before, this law of sines. So it's a over the sine of A equals b over the sine of B. Oops, that's a weird looking. Let's try that again. The sine of B equals little c over the sine of big C, capital C. Let's just do let's just draw a triangle. We'll draw a non-right triangle. So I'll draw an obtuse triangle. That's not a right triangle, is it? So there's an obtuse triangle. So what do I mean when I'm talking about this A, B, and C and capital and lowercase and all that? Well, let's call this triangle ABC. The capital letters represent the angles. So what do you think the lowercase angle, or the lowercase letters represent? The sides, right? Now, this is not just a random letter A right here, okay? This is an A that's opposite this A right here. So what do you think might be true about lowercase a in relationship to big angle A? Does it matter which one I call A? Could I call this one A? Could I call this one A? Could I call this one A? Which one of those? It's across from it, right? It's opposite. Okay, so the side that's opposite angle A is this lowercase a. You follow me? That's very, very important. Hope you guys are watching. I just don't understand doing the law of sines for goodness sakes, and you guys are giggling and laughing and not paying attention. You don't know what you're in for. That's all I got to say. I'm not trying to scare you, but I kind of am. All right? I want you to understand that this is serious. You won't have a clue of what to do if you just sit there and tell stories and giggle. This is angle A right here. Side A is opposite angle A. So I have to call that little a, according to our little formula right here. So if this is angle B, what's this side right here going to be? Call it little b. All right, that's side B. And of course, this is angle C, so this other one right here, this side opposite this angle is going to be side C. All right, that's really important that you understand that, because there's definitely a relationship between these. This side is opposite this angle. This side right here is opposite this angle B. This side C is opposite angle C. Now, if you look in the book, they actually write it like this. It's the same exact thing, though. But for some reason, I was taught with the side on the top, but it really doesn't matter, and I'll show you. Actually, you could switch back and forth. It really doesn't make any difference. And you'll see how we use this in a second. All right, so you could write it either way, but that's the law of sines. This is the way it looks in the book right here. But you could write it either way. It doesn't matter if the angle's on the top or the bottom. But remember, you can only take the sine of the angle, though. All right, but you can switch them around. It doesn't make any difference. That's the law of sines. And you say, big deal. How am I supposed to use that? Well, it's a good question. Let's see. Now, we're going to use the law of sines under a couple different circumstances, and this is what they do in the book. So when we use the law of sines, you're going to use it in a couple different situations. Here it is. You're going to use it when you have an angle side, okay, or when you have an angle side angle. You say, what in the world does that mean? Well, let's do this. Let's do the example they do right in the book, and I'll try to make it look kind of like what they do. It's an obtuse triangle again. Right. Daniel, getting all this? Alright, so here's the triangle. We'll call this 97 degrees. We'll call this one down here 21 degrees. We'll call this one 16. Alright, we'll call this A, call this B, and we'll call this one down here C. So let's do this. Let's solve for all the missing parts. Alright, let's solve for all the missing parts. I think on the worksheet that I'm going to give you today, I think they only asked you to solve for specific things, but you know, just to learn this theorem, let's solve for everything. Alright, so what does that mean I'm going to solve for? We're going to solve for this side AB. Instead of calling it side AB, what's a good letter that I can use to call it? Call it side C. How did you call it side C? Because it's opposite angle C. Good. So we'll call that side C. All right. What about this segment right here, AC? What should I call that? Instead of calling it AC, what's an easier way to call it? B. And again, why? Because it's opposite angle B. You right with me on that? And of course, the 16 would be what? Would be A. But I already know it, don't I? But I'll just call it A anyway. Now, not every single triangle is going to label it ABC. They could, you know, say solve for X. And in fact, if you look in the book, this side right here, they actually put an X here instead of a C. Right? But I'm just going to, just for the sake of using the law of sines to make it a little easier for us, I'll just make it C. Now, does it fit one of these angle side or angle side angle? Well, look what I have. I've got an angle, and I've got an angle, and I have a side that's not in between those two angles, don't I? All right, so what is that? That's angle side. Does it fit this? It does. So what are we going to use? Law of sines. All right, so we're going to use law of sines. Let's write down what the law of sines is. Now, what are we trying to solve for? We're trying to solve for two sides, aren't we? B and C. Actually, we're trying to solve for this angle, but I don't need the law of sines to find this angle. How would I find this angle right here? That's right, take the other two away from 180. All right, so let's do that. And that should be pretty simple. So let's see, 180 minus what? 97 minus 21. And that's 62. So this angle right here, just by using a calculator, is 62 degrees. So I didn't need law of sines to find that. And if you look at it too, look, this, you could also say it's angle side angle now, couldn't you? Since you know an angle, a side in between, and another angle. Right? So this fits both of them actually, angle angle side or angle side angle. So I'm definitely going to use the law of sines on this. And again, I'm trying to find a side, correct? Remember I said there's two different versions of using this? There's one where the side's on the top and the angle's on the bottom, and then there's one where the angle's on the top and the side's on the bottom. Well, what I do, you don't have to do it this way, but I think it makes things a little bit easier for you. Whatever you're solving for, that's the one that's going to go on the top, okay? So if I'm solving for the side, I'm going to use this version right here because the side's on the top. If I'm going to solve for an angle, right, which I don't really have to in this problem because I already know all three angles, I would do this. Okay, now there are times where you would put this one on top. But for this problem right here, I'm going to use this version of it. Now, even though there's three things, we don't need to use all three of them. What do we need to use? What are we trying to solve for? Trying to solve for C, aren't we? Let's solve for side, it doesn't matter. Let's solve for side C first. So what we want to do is we want two things equal to each other. We want to solve for C, right? And let's see what else we know. Well, if I have side C here, what do I have to have on the bottom? The sine of angle C. Do I know angle C in this triangle? I do. It's 21 degrees, so I put 21 right here. All right. Now, I don't want to put B here, do I? Because then I would have two unknowns and only that one equation, so I couldn't solve for either one. So let's take a look at the two that I actually know, the angle and the side that I actually know, which is A. Look, I know side A, which is what? 16, so I'm going to put the 16 up here. And I know angle A, which is 97. So what am I going to put down here? I'm not just going to put 97. I'm going to put the sine of 97. So we don't really actually use all three at the same time, do we? We just use two of them. Actually, we would have used the A and the C, right? We would have used those two together. Does that make sense? All right, so we're not using all three. So it's kind of weird to see a formula with three different things equal to each other. But we're actually not even using all three of them. We're just using two of them. So which ones do we use? We use the one that I'm trying to solve for. So I said, right off the bat, let's solve for side C first. So I decided to solve for C. So I put C up top. You got to use the angle it's opposite. So I put over the sine of 21 equals. Now this, you got to know three of the four things, right? You know the sine of 21, that's just a number you can stick in a calculator. You know 16, right? You can put that in a calculator. Sine of 97, it's just a number. You know that. What's the only thing you don't know in this situation? C, right? So what are we going to do? What's our math? I want to get C by itself. So what am I going to do? Well, you could cross multiply, and that's perfectly fine. Right. It's perfectly fine to cross multiply in this situation, but I put the C on the top for a reason, so I wouldn't have to cross multiply. All I got to do is one simple step. You guys watching? Watch the step. It's C divided by the sine of 21. How do I get rid of something that's being divided? I do the opposite, which is multiply. I don't multiply by the reciprocal. I'm just multiplying because that's the opposite of dividing. Does that make sense? So I just multiply by the sine of 21. Now, if you wanted to, you could come over here and put sine of 21 and cancel them out. But I know they're going to cancel out. That's just a waste of time to me, all right, after you get used to your algebra. But what do I have to do over here, though? If I multiply this side by the sine of 21, what do I have to do over here? Got to multiply this side by the sine of 21. Put that over 1. Everybody see that? So the algebra is pretty easy as long as you put the variable on the top, and that's why I chose to write it like this so that I could just get rid of the sine of 21 very easily. Now, what do I do now? Do I have to do any more math? Nope. Do what to this? Stick all that where? In a calculator. That's right. So let's do that in this calculator. Now again, you're going to have to practice. I've said this many, many times now. You're going to have to practice using your own particular calculator. This is the only one that I have that's online. If I had the other one, I would show you how to do the other one too. But I only have this one online. So how do I do that? Well, just multiply the top together. I'm going to go 16 sine of 21. 16 sine of 21. Everybody see that? And then what do? Divided by what? Sine of 97. So I hit sine of 97. You should practice this on your calculator. Hit equals, and I should get the answer, 5.77. What do they? It says rounded nearest tenth, so I don't write 5.7, do I? What do I write? 5.8, because that's 7 rounds that 7 up to an 8, so it's 5.8. So C is approximately 5.8. And there you go. So I took a non-right triangle, and I used this rule called the law of sines to solve for that missing side right there. Let's do the same thing with B. You think I can do the same thing? Let's go different colors this time. I want to solve for B now, don't I? So how am I going to set that up? I'm going to put B over the sine of angle B. What's angle B? 62 degrees, right? I found that earlier. Remember that when I subtracted them from 180? Equals. Now again, let's pick two that we actually know. Now, we just found C, so technically, yeah, we could pick this one and this one. But let's pick the two original ones that they gave us. What were the two original ones that I knew? The 16 and the 97, right? So let's use that again. All right, so I'm going to go 16 over the sine of 97. This looks identical to what we just did over here, doesn't it? Except we're doing the sine of 62 instead of the sine of 21. That's the only thing different. All right, so I got to get B by itself. How do I do that? Multiply both sides by the sine of 62. So I come over here and multiply that by the sine of 62, plug that in my calculator, and I'm good to go. So let's do that. It's going to be 16 sine of 62 divided by the sine of 97. And that'll give us that third side, that side B. There it is, 14.2, right? Rounded to the nearest tenth, it says. So we're going to make it 14.2. So side B is 14.2. And that would go right here, right? Let's see if those answers make sense to us. I got heads down. They need to be up. Come on, you need to be paying attention. Let's see if these numbers make sense. Do you remember that the biggest angle, or the longest side, has to be opposite the biggest angle? Right? And the shortest side has to be opposite the smallest angle. Let's see if that works. That kind of gives us, that doesn't guarantee that we got the problem right, but at least it points us in the right direction. Wouldn't you agree? So what's the biggest angle here? 97. So what should be the biggest side? 16, right? By the way, what was C? It was what? 5.8. So 16, is that the biggest side out of these three? Absolutely. That's 16, that's 14.2, that's 5.8. Which one's the smallest angle? 21, right? So what's the smallest side? 5.8. So does it kind of make sense? Absolutely does. All right. If you would have checked it, double checked it, and if the biggest side was not opposite the biggest angle, you would have done something wrong. All right. So it's a little bit of a check. It doesn't tell you exactly if you got it right or not, but it gives you a good indication. It gives you a good idea if you got it right or not. So that's the law of sines. Let's do another one where we're going to have to use it to actually solve for an angle. It's a little bit different, kind of the same, but a little bit different. I know I went a little bit quick on this, but it is recorded. Okay, it's up to you, and I do expect you to look at it. Make sure you understand. All right, let's do the law of sines again, but this time I'm going to solve for an angle instead of a side. And let's see. Let's do trying. I'm taking this right from the book. It's on the top of 583. If you want to look. Okay, so here's the triangle. Let's put some stuff in here. Let's go yellow. This is 45 degrees up at the top, right here. This is 10 on this side. This is 8 on this side. And this is X. Remember I said we can use angle, angle, side, or angle, side, angle. Well, there's another one we can use on the law of sines. Now you got to be careful how you write this one because it could be a bad word. Okay. So we'll write it backwards. Right, sangle. It's the first time I ever said sangle. Side, side, angle. So you don't want to write it backwards, okay? All right. So you get the idea. So, do we have two sides and a non-included angle? Absolutely. Here's a side, here's a side, here's a non-included angle. So we can use the law of sines on this. In fact, we're going to use it to solve for this missing angle. Okay, we found the missing side before, but we're going to find this missing angle. Let's use the letters that they use. They call this angle H, K, and J. All right, so let's take a look. After you get used to the law of sines, it's really not that bad. A lot of people tend to like the law of sines when we do this stuff. So this is probably a good one to start off with. Let's see, what are we trying to solve for? We're trying to solve for this angle, correct? This time we're solving for an angle. Remember how we wrote this formula two different ways? One way with the side on top, one way with the angle on top. So which way do you think you're going to write it this time if you're solving for an angle? Do the one with the angle on the top, okay? I think that just makes things a lot easier for us. All right? So let's do the one. So we're going to solve for this right here. So what I'm going to do is I'm going to say the sine of x over what? I look where? Opposite, right. And what's opposite that angle? It's a 10. So I just put a 10 right there. Now, what other, do we know another angle and side that are opposite each other? The 45 and the 8, absolutely, the angle H. So what am I going to put on top over here? The sine of what? Well, what is H, though? It's 45, right? It's 45. Over, what's opposite the 45? The 8 is, isn't it? So I'm going to put that over 8. Do you see how I know 3 of the 4 things, right? I know what this number is, this one, and this one. This is the only one I don't know, and that's what you want to do. Now, what are we going to do here? It's actually 2 steps to solve for this, but it's really not that much harder. What do I want to get rid of first? Yeah, the 10. Let's get rid of the 10. So I multiply both sides by 10. Let's do this in a different color. Pink. All right, so I multiply this side by 10. So what do I do over here? Multiply that side by 10. I'm going to put it right out in front. It just looks a little nicer that way. You with me? But what do I have? What do I have here? I have the sine of x equals this stuff. Do I just put this in my calculator, this stuff right here in my calculator, and that's my answer? No. I got to do, it's not the negatives. I know what you're thinking, but what do we call it? Not the negatives, the what?
Inverse.
The inverse, right. We got to find the inverse, right, to get rid of that sine. So x is going to equal the inverse sine of all that stuff. And we've done that before. That's not new, right? We've done that with the trig functions. When we found an angle, that's when you do the inverse. So when we find an angle, that's when we do the inverse. So I'm going to write 10 sine of 45. Practice this on your calculator. And we've talked about how to do this stuff on your calculator before with the trig functions. So on this calculator, I'm going to do this. I'm going to put all the stuff in the parentheses first, then I'm going to hit inverse sine. You could technically, well, let's just do it the way. Let's hit inverse sine first. Inverse sine of what? 10 sine of 45 divided by 8. Right? I'm going to close that parentheses. See what I did? 10 sine of 45 over 8. And then I hit inverse sine in front of it. Hit equals. Boom. 62 point, we'll just say, they say to the nearest degree. If they say round it to the nearest degree, do we take it a decimal? No, we just round it to this nearest number right here. Does that 1 round the 2 up? Nope. So it's just what? 62 degrees. So x is 62 degrees. And that's what that angle is right there. So it wasn't even a right triangle, or you didn't know it was a right triangle, and you figured out what the angle is. It's 62 degrees. So watch, if this is 62 degrees, what's the next easiest thing to solve for here? Angle J, and how do we do that? Subtract it from 180, right? So let's do the same thing. So it's 180, we did this earlier, minus 62, minus, what was that angle? Oh, 45, right, 45. Did I do that right? Yep. That's 73. So this angle right here is 73 degrees. We're still missing one more thing, aren't we? What are we missing? I got all 3 angles and I got 2 sides. So I'm missing what? Yeah, this side right here. We'll call it what? Instead of KH, we'll call it what? Little j. Little j. All right? So now, let's solve for j. Let's do this in a different color. If I want to solve for j, it's a side, isn't it? So let's put the side on the top. Over what? The sine of the angle it's opposite, which is what? 73. This is what we did earlier, okay? So this is a little bit older stuff. This is not brand new, but, brand new today, but stuff that we did a little earlier. Now, what two things do I know exactly? Well, I know either, well, this 62 is not exact, though, is it? What do I know exactly? I know the 45 degrees and the 8, so let's use that. So what am I going to put on top? Am I going to put 45 degrees on top? No, since the side is on the top, I'm going to put 8 over the sine of 45 degrees. All right, let's do the math again. This is the third time that we've done this. This shouldn't be that hard. Get rid of the sine of 73 by multiplying. So I come over here and I multiply this by the sine of 73 degrees. The math is easy, isn't it? The algebra is real simple. And then plug that in the calculator. Do I have to do inverse on this one? No, because j is already sitting there by itself. Okay, I'm solving for a side. You don't do the inverse when you solve for a side, only when you solve for an angle. So we're going to plug that into our calculator and see what we get. Again, you make sure you know how to do this on your calculator, because if you have a TI 30XA, you're going to do things a little differently. And we've explained how to do that on that calculator. Sine of 45, so sine 45, and that gives you about 10. This is a side, so we'll round it to the nearest tenth, so 10.8. So 10.8. So there we go. We solve for everything on this triangle. That's 10.8. We got all three sides, we got all three angles, and now we're good to go. All right. I was planning on doing the law of cosines today as well, but I think I'll hit the law of cosines tomorrow. So when I pass the worksheet, we got a few minutes here. When I pass the worksheet out, we're going to have to figure out which ones can you use the law of sines on. And there is a way to know. How is it? How do we know? If you have two angles and a non-included side, or if you have two angles and an included side, right, which means the side is in between the two angles, or what else? If you have two sides and an angle that's not included. If you have that situation, if you have any of those three situations, you can use the law of sines. Because there are times where you can't use the law of sines. You got to use something else, which is, guess what? Law of cosines. Okay, I was going to do that today, but we would just be cramming it in, and I just don't want to do that. All right? No, there's no law of tangents. It's just law of sines and law of cosines. All right? I'm telling you, this is something that you probably want to review on YouTube. You really are going to want to, because then you can stop it, take some notes, you can think about it, think about what I'm going to do next, and all that stuff. You've already seen it once. Hopefully you've already taken notes in here. But you sit in front of the computer, you watch it, you see my steps. Before I got to this step, you can back it up and say, okay, what's he going to do next? All right? Oh yeah, that's right, in class, multiply both sides by 10, and then you can see me do it, and then it kind of just solidifies what you've learned in class today. Take advantage of it, guys, okay? Don't be lazy. It's not that big of a deal. You just sit and you watch it. You don't even have to watch the whole thing, all right? Just watch the parts, just the solving part of it or whatever, all right? Okay, let me give you a worksheet, and then we'll try to figure out which problems you can use the law of sines on, because there are some problems on there that you probably have to use the law of cosines, and we haven't learned that yet. We'll learn that one tomorrow, okay? All right.